Good afternoon, class. Today we're going to be looking at 1.1, speed and velocity. 1.1, speed and velocity. Let's start with some definitions. First, distance is how far an object has moved. Distance is how far an object has moved. Displacement is how far an object has moved in relation to its starting position. You have to consider the direction. Speed is the ratio between distance and time. Average speed is the total distance divided by the total time. Constant speed is the speed that does not change over a period of time. It's going the same distance in the same time consistently. Think of constant speed like cruise control. Instantaneous speed is the speed at a given moment in time. The distance traveled in 1 second would be the instantaneous speed. This would be like looking down at your speedometer. How fast are you going this moment? Velocity is the speed and direction of an object. So velocity takes direction into account. Okay, add this to your formula sheet. Add the next 2 slides to your formula sheet. First is EWAU. Remember on the first day of school, we started talking about our syllabus, and EWAU was how we solve problems. It's our problem-solving strategy. And the E stands for the equation. You have to write the equation you're going to use. W stands for work. This is where you plug the numbers that you're given, where they should go into the formula. A is the answer. Simply do the math. It's going to be a multiplier divide problem. And what is the answer? And finally then, units are important. What are the units for what you're trying to find? Also, the equation you need for speed or velocity is V is equal to D divided by T. So V is velocity in meters per second. That will be its general unit that we use. D is distance in meters, and T is time in seconds. We'll do a few practice calculations in class. Pause the video. All right, welcome back. Now let's talk about graphs. Okay, graphing, position, velocity, and time together. So the first graph that you're going to encounter is an XT graph. This is the one you're already familiar with, where time is on the horizontal, distance or position at a given time is on the vertical, and since we're looking at constant velocity, this will be a line. So this is an XT graph. This is a VT graph, and we kind of talked about these last time. A VT graph is a velocity time graph. This is where time is on the horizontal again, but notice it's in the middle. It's in the middle of the axis, right? And velocity is on the vertical axis. And again, since we're looking at a constant velocity, this will actually be a flat line because the velocity is constant. Motion of an object. Since velocity is speed and direction, the way an object is moving matters. And there are 3 ways, and only 3 ways, that we will look at constant velocity. The first, constant velocity of an object that is not moving, standing perfectly still, will have a flat XT graph because it is going to be 5 meters away at 1 second and 5 seconds and 10 seconds. It's not going to move. It will have a 0 VT graph Because the position did not change over time, the object is standing still. The velocity the entire time is 0. The second instance is an object moving away will have a linear graph that goes up from left to right. So if we think about this here, this corner, as being the origin or the starting position, if an object is moving away, it will have a line that goes up from left to right. The velocity of that then is positive because velocity is distance divided by time. The third situation we encounter is an object that is moving toward. It will have a linear xt graph that goes down from left to right and a flat vt that is below the axis because it is going in a negative direction because it's coming toward us. So, how do you get velocity from a graph? You know that velocity is distance divided by time. Distance is the change in position. Well, that's on the vertical axis. T is time, and that's on the horizontal axis. And in an xt graph, it will be the rise, change in position, over the run, which is the change in time, or you probably guessed it, the slope of the graph. So we'll be looking at a lot more problems in class today and next time. Thanks for watching.